Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, we will discuss how to generate interrupt from a UART. So in the previous video, we have generated interrupt from timer, we have generated interrupt from external source, and today we will discuss how to generate interrupt from UART. So before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video. So guys, you know that already microcontroller will have many peripherals like UART, SPI, I2C CAN, and GPIO and external source. Many peripherals are there, and these peripherals are able to generate interrupt from each peripheral. Okay, now how to generate an interrupt from UART? The UART interrupt can be generated at least from two different scenarios, right? So how to generate? So these two are the different scenarios. So the first scenario is UART is able to generate an interrupt whenever data transfer completed, or you can say whenever data transmission buffer is empty. This is a one scenario. So whenever data transfer completed or whenever transmission buffer is empty, both are same actually. So if data transfer completed and buffer is empty, then you are able to generate an interrupt from the UART automatically. The second one, whenever you received a new data, whenever you receive a new data, it is able to generate nothing but whenever RX buffer is full. These two scenarios, very important scenarios where you can generate the interrupt. Apart from this, you can also generate interrupt from parity, or you can generate interrupt from frame error, and there are different scenarios are there. Okay, so these two are very important. So before going to the code, I will just take you to the user manual here, what they have mentioned in the user manual and what registers we have to use. So this is an important register to enable the interrupt from the UART side. That is called UART Interrupt Enabled Register. That stands for IER. U0IER stands for UART Interrupt Enabled Register. Here you can see the bit number 0 talks about RBR interrupt enable, indicating that receiver buffer, it enables the receive data available. Nothing but whenever you receive a new data, it is able to generate interrupt. And you have to make the bit number 0 to 1 to enable the RBR interrupt. Similar to that, THRE interrupt, that stands for transmitter. This is going to enable whenever transmission completed or whenever transmission buffer is empty. And similar to that, whenever there is a RX line status getting corrupted, then also you're able to generate the interrupt. Okay, so our scope only about a bit number 0 and bit number 1, but in our programming I am just showing a demonstration on this topic. That is nothing but THRE. So this is a one important thing additional to the UART programming you need to enable from the interrupt perspective. The second thing is the UART identification register, UART interrupt identification register. So this register is a kind of a interrupt status register. This register will indicate what type of interrupt occurred. Which type of interrupt occurred will be indicated in this register. You can also understand this in this register as UART interrupt status register, but here they're calling as UART interrupt identification register. So this register will have different status informations, but our scope only about this. So bit number 3 to 1, bit number 1, 2, 3, 3 bits we are going to use, and whenever it is 0, 1, 1, this is called as a receiver line status interrupt. Whenever it is 0, 1, 0, this is a receive data available. Whenever 1, 1, 0, character timeout, and whenever it is 0, 0, 1, it is THRE interrupt. Okay, so these are all the different interrupt which is going to reflect in these registers. Okay, identification register, and we have to clear that by reading this register. Okay, how to clear? I'll show you in the code. So let us jump to the code here. So code is not much complicated. Just it is an extension of our UART programming. This is my regular UART programming. So this part I have already explained in my UART programming. If you have not watched that video, you please go and watch that video, and I will update the link in the description box. Okay. So now this part I have already explained till here. So here I'm going to use a normal UART configuration, nothing but it's 8-bit mode, and I'm going to enable bordered register, and I'm going to add some divider and multiplier and so on. These things I have already explained. You go and watch my previous UART programming. I will update the link in the description box. So but today's video, today's scope is to understand the blue part, which I'm highlighting right now, line number 71, 72 and 73. Especially with respect to 71, line number 71 talks about enable the interrupt, UART interrupt, that to TX interrupt. I'm going to enable UART TX interrupt in the register called IER, LPC underscore UART 0 IER, that stands for interrupt enabled register, which is going to enable TX interrupt from the UART side. Second part is nothing but I have to enable UART interrupt. So this from the UART side, this is from NVIC side. So NVIC also we have to enable. So UART 0 interrupt, and then I'm going to set priority as 1 here. You can set any value between 0 to 7, no problem, the priority value. So this is the first point you need to understand. Second point, in the interrupt configuration, this is your UART character transmission. This already I have explained. Go and watch my UART programming video. The second important point is UART handler. In the UART handler, I need to, first thing is, as soon you reach to the UART handler, what I need to do, I need to perform some action. That action is nothing but I'm going to toggle one port pin here. The 0.0 I'm going to toggle here. Here you can see I'm going to toggle using XOR operation. So this is your XOR operation. The symbol what you are seeing, cap symbol, is nothing but XOR operation. So continuously, whenever data is transmitted, for every one character, the bit, the port pin is going to toggle 0, 1, 0, 1 like that. So P 0.0 actually. I'm going to toggle P 0.0 to indicate the ISR execution, and then I'm going to clear the interrupt from the UART. So how to clear the interrupt in the UART section? I need to read IIR register. Once if you read it, it is going to clear the interrupts which are reflecting in IIR. What is IIR? UART interrupt identification register. So here it's a kind of a status register, or you can say that UART identification, interrupt identification register. So once if you read this register, automatically interrupt will get cleared. Okay, so once the interrupt is cleared, again it will go back and it will keep on transmitting your main code. Okay, so this is your UART configuration, including your interrupt enable interrupt configuration, line number 71, 72 and 73. And then additional thing today is UART handler. So in the handler, I'm just toggling one port pin, that is 0.0, and then I'm clearing the interrupt flag. Only these two are additional things compared to our UART programming. Rest all it is same. And in while of one, this is my UART configuration function, and this is my UART character transmission function, and this is my clock configuration. So clock configuration, UART configuration, and I'm configuring my GPIO pin, that is 0.0 here, and then keep it in while of one. Just go on transmitting character ABC 1, 2, 3. So UART will transmit ABC 1, 2, 3, and every time whenever it transmits one character, UART will generate one interrupt. Whenever it character transmits A, interrupt will be generated. Whenever character B will be transmitted, interrupt will be generated, and it goes on like that. This is what we expected in the output. Now let us go to the debug window. I have already compiled, code is working, and I'll go to the debug window here. Yeah, so I have kept it everything ready. So this is my UART configuration, or you can say UART section, and this is my GPIO section. I'll just allow to run here and observe what is happening. here, this is your interrupt identification register. This part what you are seeing here, this is your interrupt enable part. Here I have enabled THRE, nothing but transmission empty, or you can say transmission completion interrupt I have enabled. And then yeah, here this is what I need to monitor, that is P0.0 I need to monitor here. P0.0 I need to monitor. It is going to toggle for every one character. Okay, so observe here. So what will happen? So this is my UART output. This window, whatever you're saying, this is my UART output window. So every time, whenever it transmits a single character, it will change its status. Observe very carefully. No, after transmission, the port pin will change its state. Correct, right? So it will transmits, and yes, so the 2 will come and state will change. Okay, so in this way we can generate interrupt from UART, and we can clear the interrupt in the ISR, and we can do some action in the UART ISR. Okay, I hope this video is clear. Coding, it's not complicated, as I told already. Coding is not totally complicated. If you know UART configuration, it is just extension of that. Just I'll take you to once again. So this is the one additional thing, interrupt enable part, and setting the NVIC part, and then addition thing is UART handler. Okay. So I hope this video is clear. So if you feel this video is informative video, click on like button and subscribe to my YouTube channel.